For the op-amp circuit shown, we're asked what value must our R2 be in kiloohms in order to set the voltage gain to 10.2 dB. We're going to assume that the op-amp is ideal, and we have our R1 right here. Well, the first thing that we need to know is that we are finding the voltage. We have the voltage gain actually. So our voltage gain is 10.2. So we need to find our R2 in kiloohms. And if we look at the notes linked below, the like button, since we are given the decibels, we want to look for expressing gain in decibels. This is about page 6. So expressing gain in decibels, we are going to have the following formula, and we're dealing with voltage here. So we are going to have, or I believe we could deal with current as well, because we are just finding our A. And so we are going to have a 20 log base 10, and then we have our AV inside of here. Now I read this a little bit backwards, but it's still equivalent, and this is set equal to our voltage gain in decibels. And so this is like VGdB. But this we can substitute for 10.2 dB. And we've went over this previously, how we would get our AV. We divide both sides by 20, and we raise both sides by 10 because of the log base power, the bottom part rule. And so if we do this, we are just going to put 10 and then raise to 10.2 divided by 20 in our calculator. We get approximately 3.26. So our AV here is equal to 3.246. Sorry, I think I said that wrong, but this is the correct AV. And so with that as our AV, we are going to look for our R2. And our R2, remember, this is gain, right? So if we're using this, the gain that we were given, 10.2, we have our AV, and our AV, now that we know it, we can look to what kind of op-amp this is and find the equivalent with the resistance. So if we go to the operational amplifier section, and we look for the exact circuit that we're given, so we have our characteristics, and we have our inverting amplifier, which looks very similar to this. We can scroll down a little bit more and find this. So using the ideal op-amp assumptions, we have these notes here that explain why this is. The voltage between the plus and minus input terminals are 0. So A is going to be infinity, and A is inside of here. And then the input current equals 0, since Ri is equal to infinity. And so our nodal analysis will be that our AV, and I'll write steps 1 and then step 2 right here. AV is equal to our voltage output over our voltage input, which is equivalent to a negative R2 over R1. And so AV is equal to negative R2 over R1. That's what we care about here. Well, we know our R1 and we know our AV, so all we have to find is our R2. So step 3 is just going to be plugging it in. We have 3.246 is equal to a negative R2 over R1, and our R1 is 6.3. I'm going to omit the kiloohms because we want the answer in kiloohms, so that's just 6.3. Divide both sides, or multiply both sides by negative 6.3, and then we're going to get the answer. That is about 20.39, and this is in kiloohms. And that's how we would look at solving this problem or something like it.